Okay, grade 7. This is lesson 4 of chapter 10. It's called simulations. Okay? The vocabulary that you need to know is all the vocabulary we have learned from lesson 1 and lesson 2 and lesson 3. You need that here. Some of them. Okay? And you should know how to read. If I told you, the probability is about reading correctly. Just like any other question in math. If you process the information wrongly, you will solve incorrectly. You must process the information correctly. Now, here is the definition of a simulation. So you will write, a simulation is an experiment. That means you must do trials. Okay, whether it's 10 of them, whether it's 20, whether it's 50, you must do the trials, okay? All right, so you will do an experiment that is designed to model an action in a given situation, okay? Like, if people came to my birthday party and I want some of them to get a present, like a t-shirt. I'm giving out free t-shirts. But I don't have enough money to buy for all of them. So I bought like a couple of them, like a little of them. So I create a device that will help me be fair to who the t-shirts go to. Or you're in my class. I want to do an activity in my class. Who do I pick? Yes, I have 20 students. I have 30 students. How will I be fair that I just don't choose somebody who talks every day? I have to be fair. I need to give everybody an equal chance to win. Okay? So because of that, because you want to be fair, you have to conduct an experiment. And your experiment depends on a fair device. You cannot use a biased device. You have to use an unbiased device. And the best device will depend on what you want to do. So we will see a couple of examples. So you will write here, a simulation is an experiment that is designed to model the action in a given situation. Okay? For example, you used a random number. Random means I cannot see. I put a lot of things in a bag and I close my eyes and I remove whatever is there. Then I see whose name did I pick, like that. I don't know whose name. I will not see the name. I will not look while I'm picking. The names will be in a dark bag. And then I just put my hand inside the bag and remove a paper. Oh, I got Shaker. Oh, I got Yamna. I won't know because all the papers are the same color. All the papers are the same size. They just have your names inside. So I'm doing randomly. It's not like I'm looking at the person. No. I wrote all your names down on a piece of paper and then I cut them like this one. You see my paper? So let's say I wrote Shaker. So Shaker has number 1 and this number 1, these purple ones go in my bag. And then I say whoever gets a 5 will come to the board to answer. That is random. So I put all these purple ones. I cut them so I'll have 8 pieces of paper. I put them in a black or a dark bag like this one. I put them here. I shake. I mix them up. And then I open my zipper. And then I remove without looking. I am not looking. I remove my paper. And then I see what number do I have. And then the person with number 7 come to the board, answer the question. So that is how what random means. Okay? So for example, you use a random number generator or you use a rolling number cube like that to simulate a rolling number cube. So you're using a random number generator to represent a number cube. Simulations often use models to act out an event that will be impractical to perform. Impractical means let me try. Like impractical means it is not easy. It is not easy to do like physically and be fair like that. So that is why you create something to so that it makes it easier and fair for you to do the activity. So let us do an example. Okay? Now, there's different devices you can choose. So now we want to do choosing a device for a simulation. We want to know which device will I use for what situation. Now, you have a coin. What is the sample space of a coin? The sample space of a coin is head or tail. Head or tail. So you will use, if you want to make, if your experiment has two choices. If your experiment has two choices, then you will use what? A coin. Okay? Because a coin has a sample space with two outcomes. Because a coin has a sample space with two outcomes. Where is my red pen? Okay. Alright. Here, what is the sample space for a cube? The sample space for a cube is 1, 2, 3, 4, 5, 6. Now, if your activity has six parts or 6 tasks, if your activity requires to do 6 things, then you will use a cube, because a cube has a sample space of 6 outcomes. That is the reason. So here, if my activity has 6 tasks, then a cube will be better. A cube will be better because, where will I write? Here. Because it has 6 outcomes. Okay? Now, if you have an activity with 5 items, like you want to choose 5 different color t-shirts. So, 5 different color t-shirts, you will make a spinner with 5 equal parts. So, if I want to choose 5 different items or activities, then I will make a spinner with 5 equal parts, because I will have 5 outcomes from the spinner. Okay? Now, what does tossing 3 coins, where will you use this for which activity? So tossing 3 coins, you will get head, 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 tail. I'm doing the sample space. You will get head, tail, head. You will get head, tail, tail, then tail, 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 head, tail, head, tail, tail, head, head. Now, if you have an activity of 8, then you use tossing 3 coins. because the sample space for tossing 3 coins is 8. See? 1, 2, 3, 4, 5, 6, 7, 8. So if your activity has 8 different tasks, what will you do? You will do, so let's say you have 8 different t-shirts. And then you say the person who gets 3 heads is the one who's going to get a t-shirt. So because you have 8 different t-shirts, you need a tool that will give you 8 outcomes. And the tool that gives you 8 outcomes is when you toss 3 coins. You're tossing 3 coins. You have a coin, a dirham, another dirham, and another dirham. You throw them up. You can either get 3 heads or 2 heads and a tail, like that. A head and a tail and a head. So, because these are the possible outcomes when you have 3 coins, so you will do 3 coins if you have an activity of 8 tasks. So if you have 8 tasks, you do 3 coins. Okay? A bag with 2 different colors. So your bag has red and blue, or yellow and green, or pink and black. So you will do this if your activity requires you to do 2 tasks. 2 tasks. If you have 2 tasks, then you will use 2 colors. If you have 3 tasks, you will use 3 colors. Okay? Like that. Alright. How can 1 out of 8 chance be simulated? You can use 3 coins. You can use 3 coins. Because 3 coins has 8 outcomes. Because 3 coins has 8 outcomes. Or you can use a spinner with 8 equal parts. 8 equal parts. And you color them different colors. 8 different colors. Okay? How can a half a chance be simulated? You can use a coin, because a coin has 2 parts. Or you can use 2 colors, 2 different colors, or 2 different colors. See, your denominator tells you this, tells you what tool to use. Okay? The denominator. The denominator told me what to do. And I know 3 coins gave me 8 outcomes. You see that? Alright. Okay. Alright. How can a chance of 3 out of 16 be simulated? A spinner with 16 equal parts of 16 different colors. Like that. How can a chance of 4 out of 5 be simulated? A spinner with 5 equal parts using 5 different colors. How can a chance of 5 of 6 be simulated? 6. I can use a cube. I can use a number cube. Or I can use a spinner. with 6 equal parts. Okay? Now, let's read this. Mariam wants 72% of her guests to win a t-shirt. She wants to give 5 different colored t-shirts. Design a device to use to simulate this event. So, she will draw a spinner, design, device. Design means to make, to draw. Device means tool, a cube, like that. So you make a spinner and you need to have 5 equal parts. I hope I will draw 5 equal parts. I don't know. Okay, I tried. 5 equal parts. Then 5 different colors. Red, blue, yellow, green, pink. Okay. Mariam wants 72% of her guests to win a t-shirt. She wants to give 5. My task is 5. My device, that's my device right there. So the device I designed is a spinner with 5 equal parts and 5 different colors. Remember, don't forget your arrow. You need to have that arrow for the spinner. When you're designing your spinner, don't forget to make the arrow. Okay? All right, let me see what is another question we need to do. Now, Miss Lillian has 36 students in her class, and she wants each day a student to come to the board and explain the starter. Help Miss Lillian to design a tool and describe your method to her. Miss Lillian has 36 students, so write out the factors of 36. Factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay? Here, I can use 2 cubes because I have a 6 and a 6. I will use 2 number cubes. I can use that. Or I can do here a spinner, 2 spinners. Spinner A. Spinner A will have we'll have 4 equal parts. Spinner 2 will have spinner A. I call them spinner A, spinner B. We'll have 9 equal parts. Okay? Then I have 3 and 12. The same thing, a spinner with 3 parts, spinner with 3 equal parts, or a spinner with 12, and not or, and They are together because you have two of them. 12 equal parts. Because you want 36. Okay? Here I can use a coin because a coin has two. So I can use a coin and a spinner with 18 parts. Like that. Okay? I don't want one. So never choose the one with one. So choose every other number. Over here, I can use two coins. So I can use two coins and a spinner. Here I can use two coins. Because two coins will give me 4. 4 outcomes. And then a spinner with 9. A spinner with 9 equal parts. Okay, here I can use 2 spinners with 6 parts. 2 spinners each with 6 parts, 6 different colors. 2 spinners with 6 equal parts. Each spinner will have 6 different colors. So the colors for spinner A will not be the same as the colors in spinner B. Okay? Colors for spinner A should be different. Should be different from B, from spinner B. So that is how you do this lesson. You'll be asked to design. They'll give you a simulation. They'll give you an activity. They will tell you design a device. When they ask you to design a device, then you know the ones we did: a coin, a spinner, a cube, a bag of marbles. Yes, you can use a bag of marbles. A bag of marbles with different colors. So devices: a spinner, a coin, 2 coins, 3 coins, 4 coins, depending on the outcomes. Okay? Now, an equally likely outcome. I want you to remember these 3 equations. Very important. When 1 equals the probability of happening plus the probability of not happening. Or the probability of happening equals to 1 minus the probability of not happening. Keyword. Make sure you read. You don't read, you'll be in trouble. Probability of not happening is 1 minus the probability of happening. Now let's go to this example here. Now I want to explain this example. Okay? There is a 60% chance of rain for each of the next 2 days. It says 2 days. I want to conduct an experiment for how many days? 2 days. I can either use, so I saw 2 days. I can do a coin with head or tail, or a bag of marbles. A bag of marbles with 2 different colors. And here they used red and blue. So 2 different colors, red or blue. So you decide what is easy. So they chose red and blue, okay? Now, what are we measuring? They said 60% chance of rain. 60% chance of rain means probability of it raining, probability of rain happening. Probability of rain happening is 60%. That's what they say. Probability of rain happening is 60%. What is the probability of rain not happening? You should ask yourself that. So you write probability of rain not happening, or probability of not raining. Happening has two P's. Probability of rain not happening will be 100%, because now we are using percent. If it was not a percent, then you use 1. If it is a percent, you use 100. Okay? It's the probability of not happening equals 100 minus probability of happening. So that is 100% minus 60% equals 40%. Okay? So, when it rains, it will rain 60% of time. If it is not raining, you will get a 40% of the chances. Okay? Describe a method you will use for that experiment. Okay? Now, how did I get 3 red and 2 blue marbles? Even though I said I'm only going to use these 2 colors, are because we are going to do for 2 days. Now, how did I get? So I have 2 fractions. I have 60%. This is happening or raining. And this is for raining. And then I have 40% for not raining. 60% is 60 over 100, which is the same as 3 over 5. 40% is 40 over 100, which is the same as 2 over 5. Now you choose which color do you want. Do you want red for raining, or do you want blue for raining? If you want blue for raining, you will have 3 of them. So you can say, we continue solving. So you will say, let the blue color marble be for rain, because blue represents water. Be for rain. And rain means 3 out of 5. That means we will have 3 blue marbles in the bag. And then you will say red color marble will be for not raining. For not raining. And how many did you get? 2 out of 5. So you will need, we will have 2 red marbles. Altogether, how many marbles do you need? 5 of them. So first, you get your fraction in percent and you simplify it. And this tells you how many marbles will be in your bag. So you will draw. Here is your bag with 3 blue marbles and 2 red marbles. Red, red, blue, blue, blue. And you have answered that question completely. So every day you will pick, the first marble you'll pick, that will represent what will happen on day 1. The second marble you'll pick, that is what will represent on day 2. So on day 1, you can have rain, you can have no rain. On day 2, you can have rain, And on day 1, you can have rain. On day 2, you can have rain. On day 1, you can have no rain. On day 2, you can also have no rain. Like that. Okay? All right. Do Aleph. See you tomorrow. You have any questions, make sure you write them down. Do example A, B, C. A, B, C. Do them. So we talk about them tomorrow.